Here is a very useful video on understanding transformations of transformed functions. We'll look into each component individually and see how it affects the x-intercepts, maximum, minimum values, and you can extend it to domain range for many functions. We are taking a cubic transformed functions in this particular example. I hope you find it interesting and useful. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the viewers and subscribers for watching my videos and posting excellent suggestions. Now here is a request from one of our subscribers who wants to understand transformation of transformed functions, right? So the topic here is transformation of transformed functions, not just parent functions. Now, when it becomes transformation of transformed functions, things are slightly tricky, especially when we have to figure out where are the x-intercepts and where are local maximum and minimum. Even domain and range, the effect on domain and range could be very critical to understand. And examination style questions normally will also involve questions based on transformation of transformed functions. This topic is not very widely done or covered in books. So in this particular video, I am going to take 8 examples, which will cover most of the kind of transformations you come across. Like in question number 1, we have horizontal translation. Then in question number 2, we have vertical translation, correct? And then in question number 3 and 4, we're talking about the stretches, dilations, right? And question number 5 and 6, we're talking about horizontal transformations, stretches, compressions, and reflections on the y-axis. And then we have some very interesting questions where we talk about transformation when absolute functions are involved. So these are very interesting topics, and I hope you will learn from these. Well, in case you want to learn from me, you can always send an email on the address given. Most of my students are doing extremely well. Some of them are right there on top of their class, getting awards and scholarships like Akshat.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student, Akshat, gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. So now, let us try to understand these questions one by one. First, let's understand the graph given to us. It is the graph of f of x equals to x cubed minus x, which has x-intercepts at 1, 0, and minus 1, right? So here, we are given a maximum, which is the local maximum, which is at minus 0.58, and the y value being 0.38. And we are given the x-intercepts at x equals to minus 1, 0, and 1. Correct? Behavior, you can see those were the fine points since the scale is too small to read. So based on this, we are going to answer the questions. So let's answer question number 1. So when we have g of x equals to f of x minus 1, what kind of transformation it is? Well, clearly, it is translation of 1 unit right. So the whole graph moves a unit towards the right. So when it does so, what will happen to the points? Well, clearly, these particular points which you see, let's say the x-intercepts, they are going to move like this, right? kind of like this. Perfect. So the new x-intercepts will be at 0, 1, and at 2, right? Okay. And the maximum values will also move 1 unit to the right. So instead of being at minus 1.8, it will be somewhere here, right? Minimum also moves. So we have the new maximum and minimum values. The graph is going to be exactly similar. So I could now connect these points and sketch my graph. Kind of like this. Is that clear to you? So that becomes the new graph of g of x. And so we can see that the x-intercepts now are at which point? Instead of being at minus 1, 0, and 1, they're now at 0, 1, and 2. Perfect. So that is how the x-intercepts will move. Let's answer part 2. Question 2 is, we are given h of x as f of x minus 1. So when it is minus 1, it is a translation of vertical translation, correct? 1 unit down. So all these points move a unit down. So this part comes here. Do you see that? So this point will come down, right? So our final point, as you can see, the graph has been translated kind of downwards. Connecting these, we get our graph. You see that? So that is h of x, which is f of x minus 1. And clearly, to find the local minimum. Now, local minimum earlier, from the symmetry, you could see that it was at 0.58 and the value was 0.38 minus. This was plus now, minus 0.38. So 1 unit down will be local minimum. Will now be at 0.58. From the odd symmetry, it is exactly at the same point, right? And 1 unit down means minus. So you have to subtract 1 from 0.38, right? So 1 minus 0.38 will give me 0. So when I take away, you get 2 and 962. So minus 0.62. You get the idea. So that is how the, minus 1.38. Minus 1.38, sorry. Let me write in different ink. Since this 0.38 will go 1 unit down. Right. Now let's move on to the question number 3 and 4. We're talking about the vertical stretch. From this particular graph, you can see how will the h of x be. Twice f of x means the graph is vertically stretched by a factor of 2. It really means that these points will be multiplied by 2, right? So the x-intercepts will remain at the same place when you do vertical stretch. However, your local maximum minimum will be, instead of 0.38, it will be times 2, right? So it will get vertically stretched, and this point also will come here. So you have a graph which will now be kind of like this. So that becomes h of x, which is twice f of x. You get the idea. So in this graph, you can see that the x-intercepts remain exactly same. However, the local maximum minimum points, their values double, right? So you can write down the x-intercepts are remain same, right? They are at x equals to minus 1, 0, and 1 as in the original function. It is important to note that whenever you do vertical stretch or compression or even reflection, the x-intercepts do not change. What change is the y values. So local maximum minimum values are changing, correct? So when you multiply by 2, they double up, as you can see here. Question number 4. You can always pause the video to answer this particular question, right? This time we have vertical compression by a factor of 1 over 10 and a reflection on x-axis, right? And vertical compression by a factor. It's important to write factor because you're multiplying it, you understand? By a factor of 1 over 10. So that means, these points are going to remain the same even when we have a reflection. But the vertical points will be very small. You see that? So our graph will be kind of like this. The values you can write here at minus 0.58. Instead of 0.38, it will be 0.038. Do you understand? And similarly, the other point also will be at 0.58, the y value being, well, that first one is negative. The second one is 0.038 positive. You get the idea. So it gets reflected, and that is how g of x will be, which is minus 1/10 of f of x. Make sense? So the question is, find local minimum. So local minimum now is where? See, local minimum is this particular find, right? So local minimum. Earlier maximum has now become local minimum. It is at minus 0.58 and the value is minus 0.038. It gets multiplied by 1 over 10 minus. Now let's look into horizontal transformations. This time we have f of 2x. Now what does that mean? And we also find the x-intercepts of this particular graph. So when we have f of 2x, that means it is horizontally compressed by a factor of half. So that really means that all these points will come halfway, right? So instead of this x-intercept at 1, it will now be at 0.5. 0 remains at 0. And you see, it just comes closer. So all these points come closer. So the x-intercepts now will be at these points, which I'm highlighting with red. The the maximum minimum values will also come closer halfway, right? So approximately I'm putting them up closer, right? So that is how it is going to be. The y values remain same. So local maximum minimum y values remain same. Their position changes. Correcting these points, we do get our graph, which is you see that. So it is kind of compressed half, as you can see. So that is m of x, which is f of 2x. Horizontally compressed by a factor of half, right? Now, where are the x-intercepts? Well, the x-intercepts have moved. Horizontal transformations always will affect the domain and the x-intercepts. So instead of being at -1, 0, and 1, the x-intercepts are at x equals 2, minus half, 0, and plus half. Makes sense? Half the values, correct? Next example here is reflection and stretch horizontal, right? So can you answer this question? N of x equals to f of minus x over 2. Okay. Well, remember that in case you really want to learn from me directly, you can always send an email on the address given. Now let's look into this particular function, n of x, which is equal to f of minus x by 2. So that minus indicates reflection on y-axis. And half indicates horizontal stretch. By a factor of 2. So basically, these points will be stretched and reflected means that, let me draw it in 2 steps, right? First is reflection. So reflection really means that this point will come on that side, right? Mirror image, right? And minimum will now come on this side. You get the idea. So the graph will actually go in the reverse direction. So basically like this. So this is the graph of f of minus x, right? So that is first thing. And then we want to stretch it twice, right? Now stretching really means that 1 will go to 2, right? So this will go to 2. This end also stretches. And these points, which are at 0.58, will now go to this particular point away. Do you see that? So the new points are somewhere there. 0 remains at 0, right? When you multiply, 0 will not change, correct? So we have a wider graph like this, as you can see, right? Make sense? So that is the graph of n of x. So you can see how they have stretched. And now, what is the position of local maximum minimum? The local maximum will now be on the right hand side and double the value, correct? Can you write down the value? Y value will remain the same, but the x value will change, correct? So 2 times 0.58 will now be at, instead of minus 0.58, gets multiplied by 2. So it will be 6 and then 1, 11, so 1.16, right? And the y value remains same, which is 0.38. Makes sense? Correct? So that is how horizontal stretches work. Now the last question here is based on absolute value functions. So we are given this particular graph and we need to sketch absolute value f of x and f of absolute value of x. Now this requires a lot of work, and so I'll take it separately in the next video. I'll also request you to record your learnings. All the transformations which we've done, if you put them together, it'll be a very beautiful idea. Well, we have dealt with this question in details. Let me just show you a part of it. Absolute value of x means that negative becomes positive, right? So if I do y equals to absolute value of f of x, it really means that wherever y is greater than or equal to 0, no change. But if y is less than 0, then reflect on x-axis. So from the graph, as you can see, this particular portion will be reflected, right? You see that? And this portion will also be reflected. So what you get is like this. So this becomes the graph of absolute value of f of x. Simple? Correct? So that is how it works. Now the last question I'm keeping for you. So I hope the concepts are absolutely clear. The last one, which is question 8, y equals to f of absolute value of x. This is your test question. You can also check our solution in the next video. Perfect. So with that, we come to an end to this beautiful video on transformation of transformed functions, right? I hope you understand and appreciate it. Feel free to write your comments and suggestions, and in case you want to learn from me, you can always contact me on the address given. Thanks for your time and all the best.